Introduction and applications of vulcanized rubber and other thermosetting elastomers. What is an elastomer? A close look at this fascinating class of polymers reveals the difference between these polymers and any other. The ability to stretch, bounce, and be flexible is unique to very few cross-linked polymers. These amazing properties are due to the polymer's ability to recover to the original shape after being deformed. These large molecules under normal unstressed conditions are irregularly coiled. When force is applied, however, the molecule straightens out in whatever direction is being pulled. What makes elastomers different is when the force is released, these molecules spontaneously return to the original normal and random orientation. The history of rubber and elastomers is very interesting. The elastomer with the longest history is that of polyisoprene, or the polymer found in natural rubber. This rubber is made from a milky latex found in various trees. If this latex is allowed to evaporate, a film of rubber is left behind which can be further pressed into usable objects such as containers, balls, and even shoes. Balls made of rubber were used by Aztecs in ceremonial games even before Christopher Columbus found the New World. On his second voyage to present-day Haiti, he saw natives using milk from trees to coat cloaks and brush into molds to make footwear and containers. Some early efforts to exploit this natural rubber by McIntosh and Hancock helped push the industry forward, but it wasn't until 1839 when it really took off. This was due to Charles Goodwin's work. His invention of vulcanization, which compounded rubber with white lead and sulfur through a curing process, cross-linking occurred, allowing the rubber to have much better properties. Though Goodyear patented his process in 1844, he died in 1860, $200,000 in debt. His name and discovery, however, live on. This process made the modern rubber industry possible and has remained fundamentally the same to this day. Natural rubber is still an important industrial polymer, and in 2008, world production reached 10 million metric tons. Vulcanization process. Natural rubber was industrialized after Goodyear's discovery of vulcanization. He accidentally mixed sulfur, lead, and natural rubber to form a rubber that had better properties and wasn't affected by temperature near as much. Looking at his mistake, what he actually did was cause the polymer chains to cross-link or form bridges that tied the polymers together. In the process, sulfur formed these cross-links. All elastomers demonstrate some degree of cross-linking. The properties of the different elastomers vary based on the degree of cross-linking. In other words, how often the two polymers are tied together. The more often bridging occurs, the more rigid the material will be. Properties of elastomers. As a class, elastomers together show these properties. They have a working range from -80 to 500 degrees, show good strength, high elongation, good resilience, good abrasion resistance, and decent resistance to oils, solvents, heat, aging, and ozone. Synthetic rubbers are derived from byproducts in the production of petroleum and natural gas. This process was discovered as a result of World War II, forced by a decrease in the availability of natural rubber. Almost overnight, the United States was producing close to 800,000 tons a year. Although natural rubber sparked an interest in the elastomeric industry, synthetics carried it on and pushed the industry forward. One of the most well-known synthetic elastomers is that of silicone rubber. Silicone rubber was established in 1940s by Kipping's work, which was based off research done by Hyde years earlier. These elastomers quickly became famous as they were used in the soles of the boots Neil Armstrong wore while taking the first steps on the moon. Other uses include silly putty, the adhesive in postage, shampoos, contact lenses, and even implants. Urethanes as a chemical type are by far the biggest group of elastomers. These generally comprise two parts, a prepolymer consisting of an isocyanate and a polyol mixed with a curative that commonly is an amine. These elastomers range in their rigidity from almost solid plastic to foams and rubber-like elastomers. Common uses of urethanes include foams for furniture, bedding, and seating. Neoprene is another fairly common rubber. Invented in 1930 by DuPont Company and first known as Duprene, the product has become popular and more than 300,000 tons are produced each year. Neoprene has many applications, including everything from tires to wetsuits and even leggings. Butadiene and styrene butadiene rubbers are both synthetic rubbers. Butadiene is similar enough to natural rubber that the properties are almost the same. The only exception is that it works much better in cold conditions. Styrene butadiene is made by copolymerizing the monomers of styrene and butadiene. These elastomers are the cheapest on the market and the highest production volume of all synthetic rubbers. This leads to uses in tires, shoe heels, soles, gaskets, and even chewing gum. From humble beginnings of tree sap to today's massive industry, the demand forced by expanding applications has pushed the world of elastomers forward. With need for newer and better materials always growing, the places these polymers will go is endless. As the understanding of this growing field continues to expand, who knows where this science will end up? Thus, elastomers provide an opportunity for the expansion of fundamental knowledge and at the same time for the development of new materials that will assist in the advancement of technology.